Hey guys, you're watching first edition, and today we'll see about n queens problem. So what is n queen problem? In n queen problems we have an n cross n board and we have to place n queens in this board in such a way that no queen marks any other queen on this board. Okay. So the solution approach to this problem will be backtracking. So what is backtracking? Backtracking is a process for systematically searching for a solution. We build the solution one step at a time, and if we hit a dead end, then we undo the last step and try the next option. Okay, so this is an example for the n queens problem. Here n is equals to 4, so we have a 4x4 board and we have 4 queens. Okay, so we have to place these 4 queens on this board in such a way that no queen marks any other queen. Okay, so since we have 4 queens, as we know, the queens can move along the diagonals, along the rows, okay, and along the columns. Okay, so we know, like, since there are 4 queens, we can place a single queen in a single row. Okay, so there are 4 rows. It means a row must contain at least one queen. Okay, so we're going to place queens row by row here, or you can do column by column, but in the solution we are going to place the queens row by row. Okay, so first I've placed my queen here. Okay, now this queen marks these spaces. Okay, so I've placed the second queen here. Okay, now this queen marks these spaces. Okay, note that I don't have any place to place the third queen, so I might have made some mistake in the previous placement, so I'll undo the second placement of the second queen. Okay, so now if you see, I've removed the second placed queen. So now I'll see the next possible option for the placement. So here I have a space. Okay, then I'll place the second queen here and I'll see if this works for me or not. Okay, so when I place the queen here, I see these positions are checked. Okay, so in the third row I have one space left, so I can place my third queen here. So I'll place it here. Okay, now this queen marks this position. So now we see there is no space for the fourth queen to place here, so in the fourth row. So we know, like, we have made some mistake in prior steps, so we would undo this last move. Okay, so I've removed the third queen. Okay, now since and we will look for the next possibility of this placement. So we had only one placement possibility here, so we might have made any mistakes before. Okay, so I'll remove the second queen too. Okay, so I've removed the second queen. Now see that I have exhausted both the possibilities here. I've checked for this position also, this position also. Okay, so it might be that this queen is placed wrong. Okay, so I'll remove the first queen too and move it somewhere else. Okay, so I've removed the first queen and now I'm going to place it here. Okay, so let's check if this works for us. And now this, if I place it here, these are the boxes which are marked by this queen. Okay, so I cannot place any other queen in these boxes, so I have a space here, so I'll place my second queen here. Okay, I placed my second queen. Now second queen marks these boxes. Okay, now I have a space here, so I'll place my third queen. Okay, now the third queen marks these boxes. Okay, now I'll place my fourth queen. Okay, so as you see, we have placed all our queens. Okay, so this is our final solution. So we have placed all our queens in this 4x4 board in such a way that no queen marks any other queen. Okay, so this is our final solution. So now we'll look for the coding of the solution. So we can represent the board using an n cross n list. So this is the example of 4 cross 4 board. So we can represent the board like this. Okay, so as you can see here, we have a 4 cross 4 board. So while calculating everything, we would it would result in a n cross n, that is n square calculation. Okay, so we want our solution to be optimized. So as you know, in an n cross n board, we place only one queen in each row. Okay, so we have an optimized solution for this, as we can use a single list in place of a two-dimensional list. Okay, and here we can record only the columns in which the queens are placed. Okay, this is a list. Okay, this is an example for a 4 cross 4 board. So we have a list which consists of 4 elements. Okay, with the indexes 0 1 2 3. At the 0th index, I store some column. Okay, j. Okay, say j I've stored. So it means at 0th row the queen is placed at the jth column. Okay, so say if j is equals to 2 here. Okay, it means the queen is placed at the location 0 comma 2, that is here. It is this box. Okay, say if I store at 0th position, I'm storing say 1. It means the queen is placed at this position. Okay, so that's what given here. Say this list name is board, then we can write board of I is equals to j. Okay, where j represents the column at which the queen is placed for that particular row. So this is the pseudocode of the program, and now we will discuss about this pseudocode. So now we will discuss about our pseudocode. As you can see here, we have our pseudocode. So this is the function place queen. We are passing here I and board. I is the row. Okay, and we pass the board. So first in this case we are passing, we want to start placing the queens from the row wise. So we are starting from the 0th row. That's why I have passed place queen 0 and board. Okay, so now we have I. So I will be here first 0. This is for the row 0. Okay, and since this is the call for the function 0, I'll write here f0. Okay, so now it says for each c such that ic is available. So c is here is for the column. So it is going to check if the columns are free. If this isn't free, it will go and check here. Okay, so here we can see this is free, so it will enter the loop. Here it says place queen at I comma c. So when at starting c will be 0, so I comma c will be 0 comma 0. So is there any space available at ic? Yes, it is. So it says place the queen at ic and update the board. Okay, so we'll place a queen at ic. Okay, and we'll update the board. We'll mark all the positions which are marked by this queen. Okay, so these are the positions marked by this queen. Okay, so now we proceed. Okay, here it says if I is equals to n minus 1. Okay, so n here we have is 4. Okay, since this is a 4 cross 4 board, so n minus 1 will be equal to 3. Okay, so is 0 equal to 3? No, it's not. So it will go to the else part here. Okay, and else part says extend solution in place queen is equals to I plus 1 board. Okay, so it is calling again the same function. It is calling itself. Okay, so this is the recursion. We'll push it to the recursion stack. Okay, so it is calling for the value of I 1. Okay, I was 0, I plus 1 is 1. So I'll write here f of 1. Okay, So this is for row 1, and now I is 1. Okay, so now again it will come to this statement for each C such that IC is available. So we'll check for each C. C varies from 0 to 3. Okay, so inclusive, these both values are inclusive. Okay, so now it will be 0, so it will check if the position is available or not. It isn't, so it will go 1. It will check if it is available or not. It isn't, so it will go to 2. Okay, 2, it's available, so it will place the queen at I comma C, that is 1 comma 2, and update the board. So we'll place the queen here and we'll update the board. We'll mark all the positions marked by this queen. So this diagonal and this diagonal will be marked by this queen. Okay, now we'll proceed. Now it will check again if I is equals to n minus 1. It isn't. Okay, so it will come to the else part. And else part, again we are calling the function place queen I plus 1 board. Okay, so I was previously 1, so it is calling for value of I 2. Okay, so for row 2 it has called, and the value of I is 2. Okay, value of I is 2. Okay, so again it will enter here. It'll search for any IC which is available. Okay, I comma C which is available. So it will start from the 0. Okay, so 2 comma 0 is available. No. 2 comma 1 is available. No. Okay, 2 comma 3 is available. No. 2 comma 2 and 2 comma 3, these all positions are not available. So after this exhausts. Okay, so it will come to the else part and it will return false. So it means here it is returning false. Okay, so it is returned false here. So now it will I can strike this off. Okay, so now we come back to this. Okay, now it says when since it has returned false, it will come back to this position because this is where the function was called, right? Okay, except this function f0 was called from here. These functions were called from here. Okay, so it will return false here, and extend solution is now false. If false means it will go to the else part and undo this move and update the board. Okay, so which move is it talking about? Since this we have striked off, it is talking about the row 1 move. Okay, and row 1 move we have placed a queen at second position, so we have to undo that move and place it somewhere else. So I'll undo it. Okay, I'll write it here. This was the case. Okay, so okay, so now previously I placed the queen here, that is 1 comma 2. Okay, so now I've they asked us to undo it, so I've undo and I've updated the board. Okay, and now it will now after the step will again go back to the loop and C will be incremented. Okay, so the value of C will be 3. Then it will check if I comma C is available. So is 1 comma 3 available? 1 comma 3, yes, it is available. So it will place the queen at I comma C and update the board. Okay, so we'll place the queen at I comma C and we'll update the board. We'll mark all the positions marked by this queen. Okay, so here it is. Okay, now it will check if I is equals to n minus 1. Okay, I is 1, it is clearly not equal to 3, so it will move to the else part. Else part calls the function place queen with I plus 1 board. Okay, so what is the value of I? It is 1. Okay, so we'll call the function for f2. Okay, now this is for row 2 and the value of I is 2. Okay, So now for row 2 it will come here, okay, and it is going to check for each c if I comma c is available. So first it will check for 0, okay. So is 2 comma 0 available? No, okay, 2 comma 0 isn't available. So it will check for 2 comma 1. Is 2 comma 1 available? Yes, it is available. So it says place the queen at I comma c and update the board. So we have placed the queen here and we'll update the board. So this all the positions are already marked except this one, so I'll mark that, okay. So it will check again, and I is equals to n minus 1. So I is 2 and n minus 1 is 3. It is now false, so it will go to the else part. Here we have place queen I plus 1 board, okay. So now it is calling for value of I 3 because I was 2 here, okay. So for row 3, if we see the value of I is 3 here, it will check if there is any I comma c available here, okay. So first it will check for 0. It isn't, there's not any space here. Then it will check for 1, then check for 2, then check for 3. So we have exhausted our loop, so it will come to the else part now, okay. It will return false, okay. So this function is returning false. So when in a recursion stack, when a function returns false, this false will be passed to the function just below that, okay. So we'll just pop it, and this false will be passed to the f2, okay. So I'm going to strike this off, okay. Now we'll go to row 2, okay. So what since it was called from here, okay, so extend solution will receive false value. So if false means it will go to the else part, undo this move and update the board, okay. So means it is asking us to undo the row 2 move, that is this move, okay. So I'll undo this. I'll undo this move. So we have this here, okay. Then we had this here, okay, and consider I've undone all the movements. Okay, this was the case, okay. Now I've undone that move and I've updated the board, okay. So now it's since this step is complete, it will go and increment c, okay. So now the c was 1, so 1 we can't place, we have to undo that. So 1 is not an option, so we'll check if there's any space at 2 comma 2, okay. So we'll check if there's any space at 2 comma 2. So is there any space at 2 comma 2? So no, there isn't, okay. Now we'll check for 2 comma 3, okay. So 2 comma 3 also it isn't there, okay. It means we had only one space here, okay. So again we have exhausted all our possible positions, and so the loop will go to the else part and it will return false. So let's strike this off, and this loop is also, this function call is also returning false, okay. So now when this will return false, it will come to f1, okay. So f1 means the function call for the row 1, okay. So row 1 we had 0 1 2 3, okay. So if you can see, already we have placed a queen here, okay. So there isn't any other possibility of placing it somewhere else, okay. We are already at the last position, okay. So when checks when it comes and increments c, okay, so the condition won't match since c is already 3 and will come to the else part, and this is also going to return false, okay. Since we have exhausted our 0 to 3 what the column value we have for the loop, we have exhausted that range. Okay, so it will come to else part and it will return false. So this will return false and this will be returned to the function called f0. Okay, so f1 was called at this stage. Okay, so extend solution is false, so we'll go to the this else part, undo this move and update the board. Okay, so it is asking us to undo the move of f0, that is row 0. Okay, so consider it undone. Okay, so I don't have any queens placed now, so now it will come after this is done. It will come to it will go back to the loop. Okay, c will be incremented and we'll check if ic is available. Okay, so we can't place any queen at 0th position, so we'll c is incremented and we'll check if 0 comma 1 position is available or not. Okay, so since the board is empty, 0 comma 1 place is available, so yes, place the queen at I comma c, that is 0 comma 1. So I place the queen and update the board. So we'll update the board. Okay, okay, so we have updated the board. Okay, now it says if I is equals to n minus 1. Okay, I is 0 and it is not equal to 3, so it will come to the else part and it calls place queen I plus 1 board. Okay, so it is calling for the value of I 1. Okay, since I was 0, so for row 1 again it is calling and the value of I is 1. Okay, so now for row 1 it is going to check for 1 comma 0 is available here, so no. Okay, 1 comma 1 is available, no. Comma 2 is available, no. Okay, so 1 comma 3 is available, yes. Okay, so at 1 comma 3 it asks us to place the queen at I comma c and update the board. Okay, so we'll place our queen here and we'll update the board. Okay, these are the positions marked by this queen. Okay, rest of all are marked already, so we'll move on and we'll check if I is equals to n minus 1. 1 is not equal to 3. Okay, we'll come to the else part, place queen I plus 1 board. I was 1, so the value of I here will be passed here, it will be 2. Okay, 1 plus 1, that is 2, so f of 2. Okay, now for this will be for row 2. Okay, since I is representing a row here, so for f of 2 means row of 2. So the second row, that is this one. Okay, so at 2 comma 0 is there any position available? Yes, there is, so it will place the queen here and update the board. Okay, I've placed my queen here and I'll update the board. It checks this column, this row, this diagonal and this diagonal, so already these are checked. Okay, yes, now we'll move on. If I is equals to n minus 1, clearly 2 is not equal to 3, it will come to this part and it says extend solution, place queen I plus 1 board. Okay, so the value of I was 2, so 2 plus 1 is 3, so here it is calling for the value of I 3. Okay, now for 3 will correspond to the row 3 and we have value of I plus 1, so I is 3 here. Okay, 3. Now it will check for the 0th position, is it available or not? No. For the first position, no. For the second position, yes, it is available, so it will come and place the queen here and update the board. Since all the positions are already marked, we don't have anything to mark now. Okay, so it will come here and it will check if I is equals to n minus 1, so 3 is equals to 3 is true, so this is going to return true. Okay, so if this is returning true here, okay, So now it will come to the part F2. Okay, now strike this off. Okay, now since it has come to F2, okay, it is returning true. Okay, means F2, this all these functions were called except our F0, all these functions were called from here. Okay, so now the value of extend solution is true because this function is returning true. So if true, then return true. Okay, so now F2 is also going to return true, so this is also returning true. So I'll strike that off. Okay, so again we'll come to F1. Again extend solution will be true for the case of F1. If extend solution is true, then return true. So now this is also going to return true. Okay, and again it will come to the next F0. Okay, so this is gone. Now we have F0 and this is returning true. F1 was called from this position, so this is returning true. Okay, so when this returns true, then extend solution and return true. So again this is also returning true. Okay, so when this returns true, this function was called from here. Okay, so at the driver code of the program, we can have a statement like if place queen 0 comma board, then print board. Okay, and pass the board here. Okay, so we can have the statement. So if this function at last returns true, which then we'll print the board. Okay, then that means we found our final solution. So our final solution is this. Okay, this final board. So we have successfully placed all the queens in such a way that none of the queens mark any other queen. So that's it. That's our final solution. Now we will see how to update the board. So as we have seen previously that we have one-dimensional and two-dimensional representations of our board. So in two-dimensional we can create how do we represent the attacks of the queen, like how do we represent that a particular queen is attacking these positions. Okay, so we can have n cross n attack grid. Okay, there we can represent a particular cell, a particular box as one. We can assign a value of 1 to it if it is attacked by a queen, or else we can assign it 0 if it is currently available for any other queen to be placed on that position. Okay, so as you can see in this example, we have two queens here. We have placed two queens, so these queens attack these positions which are marked by 1. Okay, so but there is an issue with this representation. Okay, the question comes, how do you undo the effect of placing a queen? Okay, and when you undo the effect of placing a queen, which attack position are you going to reset to 0? Okay, so these are the questions, like say if I want to undo this placement, so how do I do that? Okay, and what attack ij should be reset to 0? How do you know, like when I remove this queen, okay, from here, how would you know which box to reset to 0, which attack box you have to reset to 0? Okay, since the some blocks are attacked by both the queens, like q1 also and q2 also. Okay, so how do you know which block to we have to reset to 0? Okay, so that's an issue here. Okay, so to solve this problem, we can do this in this way. Like we know that queens are added row by row, and a number of queens are 0 to n minus 1. Okay, so we can record the earliest queen which attacks this each square. Okay, so say if the board is attack ij, okay, this is a two-dimensional board, then we can set it to k if it was attacked by the queen k first. Okay, and we can reset the attack ij to -1 if it is free. Okay, and when we remove any queen, we can reset, we remove queen k, then we can reset all the places marked by k back to -1. So in this way we can maintain and update the board. So as you can see, I have q1 and q2 here, and for the places where q1 is attacking, since it was placed first, so I have marked all the boxes as 1, and when q2 I have placed q2, I have marked the positions which were not attacked by q1 but q2, so I have marked it by 2. Okay, so when I remove q2, I'll replace all the values which were marked by q2 by -1. Okay, so in this way we can work out the recording the attack of the queen. Okay, but this solution involves order and square calculation. So do we have a better way? Yes, we do. Okay, so we'll see how. So a box can be attacked if there is any queen in the same row, okay, in the same column or in the same diagonal. Okay, we know that. Okay, so since we are only concerned with the queen which marks the position first, so we can create 4 separate lists for row, column, a diagonal northwest to southeast, then the diagonal northeast to southwest. That is the 2 diagonals. This is northwest to southeast, and this will be northeast to southwest. Okay, these are the 2 diagonals we have. So we can record the 4 separate lists for row, column, diagonal 1, say diagonal 2. Okay, so we can record which queen marks these positions. So here we have a row. Okay, so marking a row is very easy. Okay, say row 0 is attacked by queen k. If it is marked, we know we cannot place any queen in this row. As we have done for the queen, we can have at the 0th index we can store which queen is attacking that row, or whether it is free. Okay, that thing we can denote, and we'll see how it is done. Okay, and similarly for the column. Okay, and the row and column was quite easy, but how do we represent and how do we get to know if the particular diagonals are attacked? Okay, so we'll see how it is done. Okay, so here if you see, now we are considering the diagonals which are northwest to southeast. Okay, so if you see here, now if we subtract the row from the column, that is j minus I, so we'll get 0 minus 0 is 0 here. So we'll see along this column that all the values result to 0. Similarly in this diagonal, along this diagonal, all the values, that is 1 minus 0, 2 minus 1, 3 minus 2 result to 1. Okay, similarly for this diagonal, -1. Similarly the last diagonal here will result to the value 3, and the last diagonal here will result to the value -3. So it is varying from -3 to +3. So in between these values, if we count, we'll get all these diagonals, we'll get a value for all these diagonals. Okay, so that is what is said here, that the range of the diagonals will be from minus and -1. That is, this is a 4x4 board, so n will be 4, so -3 to 3. Okay, so this will be the range for these diagonal. Okay, so similarly for this northeast to southwest diagonal, we have we will add both the I and j values. Okay, so if we add both the values, you can see the sum of this sum along these diagonals will be always 3. Okay, sum along these diagonals will always be 4. Sum along these diagonals will always be 2. Okay, so in this way we can find out like which diagonal is attacked by any queen. Okay, if a diagonal is attacked by queen or not. Okay, So this will be in the range of 0 to 6, that is given here. So this can be done in O of n representations. Okay, so now if we see as we have decided, we will denote r of I is equals to 1 if row of I is attacked, okay, and I is 0 to n minus 1. Okay, the column of I will be set to 1 if it is attacked. Okay, and the northwest to southeast of I will be set to 1 if this diagonal is attacked, and similarly for this one. Okay, and here as we have discussed, we have given the ranges for that particular list. Okay, so now how do we update a board? Okay, so if for updating the board we have certain operations, that is how do we check if it is free? So to check if a particular space or a box is free, we'll check if row I column j, this diagonal first, then the second diagonal is set to 0. If this value is 0, that means it isn't attacked by any queen and we can place the queen there. Okay, so how do we add a queen? When we add a queen, we set the board of I to j, that is we are recording the column in which the queen is placed for a particular row. Then we set row I column j, then northwest to southeast diagonal j minus I, and southwest to northeast diagonal j plus 1 to 1 1 1 1. Okay, so we are marking all the boxes which are attacked by this queen, okay, which we are placing now. Okay, so this is how we add a queen. To remove a queen, we set the board of I back to -1. Okay, and then we set all these values back to 0. Okay, this is how we update the board. Okay, so to implement this, rather than using separate lists, we can use a nested dictionary. As you can see, say board is a dictionary and we are using the queen, row, column and the diagonals as a key to it. Okay, so we can use it with the nested dictionary. Okay, it would be more convenient to us. Okay, so here is the final code. So as you can see, this is our main function, and since I have discussed this in the pseudocode, I am not going to discuss it here. Okay, so this is our main function. Okay, this is the function to add the queen. This is the function to remove the queen. These things we have discussed. Okay, this is a function which checks whether the that particular space or box is free or not. Okay, this is the function to print the board. Okay, and this is the function which initializes the board at the beginning. Okay, so let's run this. So I'll enter 4. Okay, so it gives me positions like 0, 1, 1, 3, 2, 3, 0 and 3, 2 of the these are the positions of the queen. We could place the queen so that it satisfies a condition and no queen marks any other queen. Okay, so I've created one more, I've tweaked this code a little bit and I've created one more program. It shows the better representation of what's happening. As you can see here, it shows the board also. So you can I'll pass these codes in the comments, so you can take as you can have a look from there. And I've tweaked it a little more, and this code shows every step of whatever is happening, the single steps, like when we place the queen or when we undo some undo some placements. So all these things are shown here, so you can execute these codes and you can have a look and you can interpret on your own. Okay, so that's it for this video. Thank you. That's all for this video. See you in our next video. If you liked our video, please do like, share and subscribe.